Imagine a new planet having the same density as that of Earth, but it is 3 times bigger than the Earth size. So we are considering a planet and Earth. So new planet having same density as that of Earth. So we can say that both are having same density, but 3 times bigger than the size of Earth. So if you are just considering the radius of Earth is r, then its radius is 3r. If acceleration due to gravity on the surface of Earth, if you are taking it as g, and that on the surface of new planet as nothing but g dash, so Rm is to find out the value of g dash in terms of g. So we can write the relation between acceleration due to gravity, radius and density. That is g is equal to gm divided by r square. So we can write g into this mass, we can take it as something but density into volume divided by r square. Further we can write it as g into rho into volume can be written as 4 by 3 pi r cube divided by r square. So this r square and r square over here get cancelled. So we can write g into rho into 4 pi into r divided by 3. So we can write this acceleration due to gravity is directly proportional to, according to this question, this density is same in both the situations. So that is a constant, 4 is a constant, pi is a constant, g is a constant and 3 is a constant. So just g is directly proportional to r. So we can write g dash divided by g is equal to nothing but r dash divided by r, where g dash is acceleration due to gravity on that planet and g is acceleration due to gravity on Earth, and r dash is nothing but 3r, and the value of r is taken as nothing but r. So we can write this is equal to 3. So g dash is going to be 3 times of g.